Bismillahirrahmanirrahim. This is the first lecture about the colligative properties, and I will explain briefly about the colligative properties, and then in the next lectures I will explain one by one each colligative properties in detail. So you know the formation of the solution, and the solutions are the homogeneous mixtures. And this is the way how the solutions are formed. That means the solvent is going to interact with the another solvent molecule with some sort of the intermolecular forces. And similar is the case with the solute. And for the solution, that means when the solute is going to interact with the solvent molecules. So solutions are formed when these three kinds of forces are similar. And you know that the very common rule that like dissolve like, and in this case, if you dissolve a sodium chloride in water, that means sodium is having the ion forces and the water is having the dipole forces or the hydrogen bond. And when the sodium chloride is dissolved in water, then there is the formation of the ion dipole forces between the ion from the sodium or the chloride and the dipole forces from the water molecule. And this is shown over here. Let's put this is the chloride sodium when it dissolves in the water. And this is the molecule of a water. And the colors of the atoms are shown over here. That means this chloride would be interacted with the hydrogen, the bonding between the hydrogen and the chloride, or simply you can say this is the one of the dipole. This is the partially negative charge and this is the partially positive charge. And partially positive charge will interact with the chloride, and it is surrounded by the water molecule, and this is called the dehydration. And in a similar way, the sodium is also interacted with the oxygen present in the water molecules, and these forces are also called the dipole and the ion forces. So this is also the process, this process is also called the solvation or the hydration process. But particularly this is the hydration process because the ions are surrounded by the water molecules, and the solvation process is when the ions like sodium are surrounded by the chloride ions, or the chloride ion are surrounded by the sodium ions, then we will use the term solvation. So in this way, the solutions are formed, and one of the thermodynamic parameter is the entropy, and the entropy change, or here we call it entropy of the solution because we are preparing the solution. And there are two ways in which you can prepare the solution. If you dissolve a solid into the liquid, and then it will form a solution. And you have a look over here, the entropy of the molecules are increases because the solid is having less entropy, and as compared to the solution, and the liquid is also having the less entropy as compared to the solution. So entropy is increases over here. In a similar way, if you dissolve the liquid into another liquid, then the entropy of the solution will also increase. It is having more entropy as compared to the individual liquids because there will be more randomness in the solution between the molecules of the liquid 1 and the liquid 2. So entropy will increase in this way, but there may be the different case with the change in enthalpy, and we call over here, this is the enthalpy of the solution or the heat of the solution, and this may be a negative and this may be a positive value. And very briefly, because the energy is required to break the intermolecular interaction between the solvent-solvent molecule. So energy is required. That means the change in enthalpy must be a positive, and there should be also the requirement for the energy to break the intermolecular interaction between the solute and the solute, and energy is required. That means the change in enthalpy is positive, and you call this, it is the endothermic process. And when the solutions are formed, that means there should be interaction between the solvent molecule with the solute, and then the energy is released. When energy is released, this is called the exothermic, and the change in enthalpy is minus or negative. So what would be the net effect? This is the first case. In case the energy release after the formation of the solution is more as compared to the absorption of the energy for the solvent-solvent or the solute-solute molecule, then the net change in energy of the solution would be negative. And this is the reverse case. In case the energy absorbed is more as compared to the energy release in case of the solution, and then what would be the net change? Net change you can see over here, from here to here. That means energy is required or the energy is absorbed, and that means the change in enthalpy or the enthalpy of the solution or the heat of solution in this case is positive. That means net change in energy is required. So what is happening over here? That means the solutions can be prepared exothermally or the endothermically. So let's suppose this is one of the case. Lithium chloride is having minus 37. That means it is the exothermic, and the entropy, of course, is positive. That means this is the spontaneous way to prepare the solution. But sodium chloride is also dissolved. When it is dissolved, it required the change in enthalpy, and the value is 3.9 kilojoule per mole. And of course, in this case, entropy is also increases. So I had, like I have explained before, the change in entropy is increases all the time because the randomness is increases, but the change in enthalpy may be the negative and maybe the positive. So what would be your final solution towards the preparation of the solution? And now you can explain the spontaneity or the formation of the solution with the change in free energy by using this equation, which is the Gibbs free energy equal to delta H minus T delta S. So if the value of the delta G is negative, the process is spontaneous and substance dissolved. That means you can prepare the solution. So in case the change in free energy is positive, the process is not spontaneous. That means the substance does not dissolve and you cannot prepare the solution. So based on the value of the change in free energy, you can easily decide which solute is going to dissolve in that particular solvent or not. So based on this one, that means solutions are going to depend on the mass of the solute, and the one of the example is given over here as I have explained before. If you want to dissolve the sodium chloride in water, so you know that the pure water boils at 100 degrees centigrade and it freezes at 0 degrees centigrade. So for example, when you dissolve 1 mole of the sodium chloride in 1 kilogram of the solvent, which is the water, that means this is the 1 molar. Molar mean 1 mole of the solute per kilogram of the solvent. Then the water boils at 101 degrees centigrade and it freezes at minus 37 degrees centigrade. So what is happening over here? the boiling point is increased, but the freezing point is decreased. And this is going to depend on the amount of the solute you want to dissolve in a particular solvent over here. That means, and the boiling and the freezing, that is the boiling of the solution or the freezing of the solution. You can simply say that the boiling or the freezing of the solvent in the solution is elevated, and the freezing point of the solvent in the solution is depressed, and we can call them the elevation of boiling point and the lowering of or depression of the freezing point. And these are called the colligative properties. That mean they depend on the amount of the dissolved solute, but not on its chemical identity. Chemical identity will remain the same. Sodium chloride will remain the sodium chloride and the water will remain the water. But what is happening by changing the amount of the solute, the boiling point and the freezing point is going to change, and this is called the colligative properties. And these are the four different colligative properties. And in comparing the properties of a pure solvent with those of a solution, and the first one is the vapor pressure of the solution is lower. Second is the boiling point of the solution is higher. Third one is the freezing point of the solution is lower. And the fourth one is the osmosis. Osmosis also depends on the concentration of the solutions. And this is the migration of the solvent molecules through semi-permeable membrane and occurs when solvent and solution are separated by the membrane. So these are the four colligative properties, and in the next lectures, I will explain one by one in detail, and will also explain some of the learning objective and what is the importance of these colligative properties to learn under the heading of the solution chemistry. So I will explain the next lectures.